Hello class. In our last class, numerical based on elevation in boiling point, and now today we are going to see the third colligative properties, depression in freezing point. So first we will go through the definition, then we will come across the expression that is required for the numerical for this colligative properties. So freezing point is the temperature. Freezing point is the temperature at which the vapor pressure of the solid and the liquid in equilibrium are same. That means freezing point is that temperature at which the vapor pressure of solid and liquid remains the same. On addition of non-volatile solid in the liquid, we know that the vapor pressure of the solution gets lowered and the solution freezes at lower temperature. That means the solutions freezes at lower temperature than that of pure solvent. Therefore, say for example, if you understand through this graph, then this is the graph for solvent and this for solution. Along the x-axis we have got temperature and along y-axis we have got vapor pressure. Now, the temperature at which the solid and the liquid will have the same vapor pressure we call it the freezing point. So in case of solvent, the corresponding freezing point corresponds to T naught, that is freezing point of pure solvent, you can say. And for the solution, since the freezing point gets decreased, let that be Ts, that is freezing point of solution. So the difference in this freezing point is known as depression and freezing point, because there will be decrease in the freezing point. So the difference in the freezing point of the pure solvent T naught and the solution Ts is known as the depression in freezing point, that is delta Tf. So delta Tf is given by T naught minus Ts, that means freezing point of pure solvent minus freezing point of solution. Now, from experimental observations, it has been found that depression in freezing point is directly proportional to molality of solution. Now, the derivation below this is same as we have seen in case of elevation in boiling point. So, depression in freezing point is directly proportional to molality of solution, that is delta Tf proportional to m. Now, to remove this proportional sign, we will put the sum constant, that is Kf. Over here, Kf is known as molar depression constant, or we call cryoscopic constant. Now, if you want to define this molar depression constant or cryoscopic constant, it is defined as the depression in freezing point when molality of the solution is unity. Say for example, from that expression, if you replace that the value for m molality as 1, it will become delta Tf equals to K. That means the molar depression constant or cryoscopic constant is equal to the depression in freezing point when molality of the solution is unity. That is when 1 mole of solute is dissolved in 1000 gram of solvent. Now we have got this expression. Now, as we know, molality is given by number of moles of solute by 1 kg of solvent, so which is given by small w by small n, capital W by 1000. So it will be, you will get this equation. So this we can express, this we can replace in place of m. Now from this expression we can get the value of m equals to, that is molecular mass of the solute, equals to Kf, that is molar depression constant or cryoscopic constant into 1000 into small w divided by delta Tf, that is depression in freezing point, into capital W. Now in our next class we will be doing the numerical based on these equations.